All right, hi guys. Welcome to the new chapter. All right, okay. In this new chapter of DC circuits, we are going to just look at two main types of circuits. You can see on top. I think you're quite familiar with this. These are known as series circuits. These two are series circuits. That means one bulb is after another, and the bottom is parallel circuits. You see, one on top of the other. So one is one after the other is one on top of the other. They call the bottom one parallel because the wires appear to be parallel to each other. You can see. Okay, there are two main instruments that we're going to look at. One is the current, with this square thing that you see actually measures the current. That means how fast the charges actually move. The other one, this black box here, is actually measuring this thing called the potential difference. Okay, so when we measure potential difference, what actually happens is that difference means we have to find the difference between the start and end point. So for example, if I want to find the potential difference of this light bulb, I have to put one probe before, one probe after. Okay. All right. Let's just zoom in on the first one. Let's do the zoom in with the first one will be on current in the series circuit. Okay. What do you notice? If I were to bring this ammeter here, I'm measuring all the current. Oh, it's all 1 ampere. What about over here? Let's move to the top. 1 ampere here. Let's move it. All right. Oh, seems like it's all 1 ampere. You can see here, right? So here, 1 ampere here. 1 ampere as well on the bottom. Oh, it's all 1 ampere. So then we can conclude that current in a series circuit is always the same. That's right. Okay, what about potential difference? Let's move on to the second one. Potential difference, and what I mentioned earlier, we now use this thing called the black box, or rather known as the voltmeter. Okay, voltmeter, when we measure potential difference, I must have one probe before the light bulb and one probe after. So it measures about 10 volts. Okay, if I move on to the next light bulb, after and before, so measure the difference in potential. Again, 10 volts. So if I have this bulb to be 10 volts and this to be 10 volts, what about the potential difference throughout? You can see, oh, it's 20 volts. So what can we conclude here? 10 plus 10 equals 20. So that's for potential difference across a series circuit. Okay. All right, let's move on now to parallel circuits. Okay, you can see the current here before is 3 amperes. Once it breaks off, it's 1 ampere. At the bottom, 2 amperes. So do you see any trends? 3 equals 1 plus 2. Okay, so 3 again equals 1 plus this one, 1 plus the bottom 2. Okay, so I total equals I1 plus I2. That's for current. Okay, in a parallel circuit. And finally, potential difference of a parallel circuit. Okay, this is interesting. Check this out. If this is total will be about 20 volts. 20 volts. Oh, okay, stop playing. Let me just give me a second over here. Just refresh my screen. And boom. Okay, let's see. Let's put a probe before this top light bulb and one probe after the top light bulb. You can see the potential difference about 20 volts. Look at the bottom one. The bottom parallel one is also 20 volts. Okay, what about total? So if I put before and after both the light bulbs, also 20 volts. So what can we conclude now? For parallel circuit, potential difference is always the same. Okay. All right. Hope you enjoyed this simulation, observing of patterns. Okay. Next, we're gonna go straight into the textbook. All right. Okay. See you soon in my next video. Peace.